is for Mathematical Methods. It is the Masterclass Exam Prep question 14, the second part from E onwards. So now we have a composite graph. Remembering the composite graph will be H inside of F. So this sits where X is. So that's the connection between the previous part of the question, where we have a polynomial as the power inside of an exponential. So why does the composite exist? Well, it would exist if the range of the inside, which is H, is a subset of the domain of the outside, which is G. So this is G, which is an exponential. So domain of G is all real numbers, and the range of G will be 0 to infinity. So the range of G is all real numbers, and we have this parabola, which looks like a perfect square. So if I clear all of that out, and I'm looking at it with a restricted domain of x bigger than or equal to -1, and now I graph that again, it's going to have a range of 0 to infinity. So it's got a domain of H of -1 to infinity, and the range of H is 0 to infinity, and the range of H is 0 to infinity. Therefore, G of H of X exists. So I've explained it. Show that the inverse is this. Okay. So running out of space here. I know y equals e to the, that's the same as x plus 1 squared. E to the x plus 1 squared. And if I'm looking for the inverse, x equals e to the y plus 1 squared, which means y plus 1 squared equals log base e of x. Y plus 1 equals plus or minus the square root of log base e of x. So y equals -1 plus or minus the square root of log base e of x. However, because of the restricted domain and range, I only take the positive square root. Therefore, shown. Consider this family where we're going to add a to f of x. So what have I got here? I've got e to bracket x plus 1 squared, but that's given x is bigger than -1. So if I graph that and have a look and see what I've got this. And if I sketch the inverse, that's my inverse. So now if I plus 1 to that, this one with the restricted domain, it goes up. And if I sketch its inverse, no, that one, yes, there it is, it's gone further away. But a is negative, okay, so how about if I make that -1, I now sketch all of this, and I sketch its inverse. And if it was -2, so the effect of the A is dropping this down and sketching the inverse, it's moving the inverse across, and now I have an intersection point. Okay, So what's going on? So if I have y equals e to the x plus 1 squared plus a, and I swap and make that y and make that x, x minus a equals e to the y plus 1 squared, then the inverse is going to be -1 plus the square root of log base e of x minus a. That's the inverse in terms of a. Find the value of a corresponding x value for these graphs to be tangential, that is, they touch each other. So if I get an exponential and I've got a logarithm and I want them to touch, then their y values have to equal and their gradients have to be equal and equal 1. So what I'd like to do is I'd like to make e to the x minus 1 plus 1 squared plus a equal x, and the derivative of e to the x plus 1 squared plus a to equal 1, and solve for x and a. So what am I saying? I'm saying that its derivative has to equal 1 because its gradient has to be 1, because where they will touch each other will be on the line of y equals x, and the gradients have to equal 1. Why do I say that? If I was to go here, they have to equal each other, and the gradients have to equal each other, and for inverses the gradients will equal 1. That's where it comes from. And instead of making them equal to each other, I'm making one equal to x, which is the same as making the f equal its inverse by making it equal to x. So where's my calculator? So I've got this, but I've got plus a, and I wish to make that equal x. That's equation number 1. And if I take this and I take its derivative with respect to x and make it equal 1, that's equation number 2. And if I open up simultaneous equations, I take equation 1 and I take equation 2, and I solve that for a and x. So x equals negative 0.58. 2 decimal places. Let's just double check that. 580, and a equals negative 1.77. So if I was to then graph them, so if I take this and I make a equal to negative 1.7, and I get a new graph analysis. And I take this graph and then I sketch its inverse. It should just touch, and it does. Beautiful. And at that point where it touches, the gradient will be 1. Okay? And then lucky last, so we have the function, we have its inverse, and it's bounded. Okay, so when a equals 0, I drew it before and I had this and I had that. And as a goes to -1, it moves this one down and moves this one across. At the moment, there is no bound area. Where they look like this will be where my area bound will be the biggest, so therefore A has to go down 2. So A equals -2 should be the point. Now I found that out from my trials previously. So if I have, let's say I get rid of all of that, and I take this, and I made that a -1 keyboard given x is less than or equal, or bigger than or equal to -1. And I want to put the restriction in there so that when I graph it, I only get it only draws the bit of the graph that I'm interested in. Analysis, sketch, inverse, and there it is there. Now I know the inverse is -1 plus log base e, the square root of log base e of x plus whatever a is, so it's going to be +1 in this particular case. And if I graph that at the same time, that's going to go on top of there. Beautiful. So if I change this to -2, I change that to +2, I'm going to get this, I'm going to get this, and I'm interested in the x values of the intersection. So analysis G solve intersection, -1, so x equals -1, and x equals -2.5311. Two five three one one, and I want to do it to 3 decimal places, so -0.253. And that will give me that area. And while I'm here, let's find that area. Analysis G solve integral intersection, except. Move to the next one, except. And that area should be 0.2266. Giving maximum area to 2 decimal places. So area equals 0.23 units squared. And I've got to write a definite integral. Okay, so the definite integral will be from -1 to -0.253 of, there's a number of things I can do here. I can do top curve, which is f of a -1 minus bottom curve, which is f of a dx. I could write 2 lots of the integrals from -1 to -0.253 of the top curve, which is f inverse of a minus x dx. Or I could do 2 -1 to -0.253 x minus f of a dx, or I could include the equations.